Welcome to our new supporters, Chris Jackson and Dan Barrett. I appreciate the support. Well, the clouds have closed in on us and we have some showers out there. Everything looks very stratified this afternoon and the clouds have a high-based look. Local meteor observations are showing 3,800 with a 10,000 foot broken layer. So a lot of it is actually altocumulus. Well, I think a good place to start is the hemispheric pattern. This is up at 300 millibars, about 30,000 feet. And I think we're getting into a more seasonal weather pattern here. Looks like the large Hudson Bay low has kind of subsided, and you can see it has less of an influence at this point west of the Appalachians. We're still hanging on to a little bit of a Rex block pattern here on the west coast. You can see that little upper level high there with a upper level low along the same meridian line with a high north of that. So that could keep the pattern a little bit locked up there, but the flow overall is getting very strongly zonal, and that's breaking the storm track into California. And we're still hanging on to this ridge here in the high plains. And on the east coast, still a very deep low there. So they're not totally out of the freezer just yet. And then zooming in on the 500 millibar chart with the dynamics. There's the jet stream coming onto the west coast there. Have some evidence of an upper level jet right there. In fact, let me just clarify this a little bit. Jet is actually going to be right about there. And we're seeing a jet max locating right there, coming on shore there near Fort Bragg. Upper level ridge is located there, and we can see some evidence of an upper level low across central Texas. So where would we expect to find the fronts? This is a pretty good reference here. This shows the relationship of fronts to the upper level patterns. So here we have an upper level trough and here an upper level ridge. And you notice that the front is downstream from the trough and upstream from the ridge. In other words, it's to the east of the trough and to the west of the ridge. Another important thing to point out is the jet stream axis. It runs about like that. And this shows that the baroclinic low is located pretty much right on the jet stream axis, about halfway between the trough and the ridge. The cold front points towards the warm air near the trough and the warm front towards the ridge. So using this conceptual model of where the surface fronts are, we can apply that to our upper level chart. And this is a good thing to memorize. So applying that to our chart, let's see. I'm going to mark the troughs in blue. So here on the east coast, the trough is really huge, but I'm going to go with where the sharpest curvature is, so that'd be about right there. Okay, then the ridges. I'm going to put one there in the highest curvature, and again, another one right there. And then the jet. Let's draw that. That's going to be near where we have the tightest packing of the height lines. There goes my phone. And let's see, it's going to run about like that. So this tells us that we would expect to find a surface front right about there, the cold front extending down, maybe something like that, and the warm front like that. And a similar pattern here, maybe something like that, and there's the warm front. And what do we find in here? This area right here. This is west of the trough axis and east of the ridge. That's actually going to be where the baroclinic high is, in other words, the polar high. So it's going to be located right about there. And this is kind of important because if our baroclinic high is right there, that tends to be a cold high coming out of the polar regions like Canada. So on the east side, we're going to find cold air advection. And that's what supports that troughing that you see right there in the upper levels. Same thing on the other side. Here we have, in the anticyclonic flow, we have southerly flow bringing up warm air into the western Midwest, and that helps build this ridge axis. So pretty simple. Okay, so now we have an idea what to find on our surface chart. Now, they're not always going to agree. In fact, we always find discrepancies, but that is actually good to know. Sometimes that kind of information comes in handy. So this is our current surface chart, and I did not look at this until just a few minutes ago. And it's not because I wanted to show off or anything like that. It's because I wanted to avoid a problem called anchoring. Yeah, you can see this thing called anchoring, and I'm going to talk a little bit more about this maybe later this week. It's cognitive bias where an individual depends too heavily on a piece of information offered, the anchor when making decisions. So I started with my upper level chart instead of the surface chart, and I let the upper level chart guide me as to where I thought the surface patterns would be. And only after I completed that did I look at this, and I've noticed that, yeah, the patterns, they kind of match up. That surface low is kind of right in the area where I expected it. The cold front structure pretty much in the ballpark. The Bear Clinic high right there, and the upper level low well offshore. So this process helps to develop consistency between the upper level and the surface chart. And there's a closer look at our conditions there in the southwest. Pretty good southwesterly flow in the El Paso and New Mexico area. That's going to be the air back behind the dry line, and that looks to be located around the Bakersfield area, Sanderson, Pecos River Valley. It's not very well defined, but we do see a difference between the 60s dew points at Del Rio and Junction and the 40s there in Fort Stockton. And we've got a warm front set up right there in the southern part of West Texas. Now, it is May, mid-May at that, so anytime we have a front like this, that means there is potential for thunderstorms due to the forcing along that front. The only downside that we tend to have is the upper level patterns are usually found well up to the north, so that could mean a low shear pattern for Texas. Also, we have an upslope regime there in far west Texas and eastern New Mexico. Dew points aren't very high in that area, only low to mid 50s, but that could always change later during the day. The tropical air mass is south of a Waco-San Angelo line, and north of that, cool air with low ceilings and patchy drizzle. And let's take an even closer look at that. We'll go to the Texas Tech Mesonet site and look at these areas here. Here's our Texas Tech Mesonet plot. The best way to use this is to start with our tropical air, which is out over this region here. That's going to be around Junction, Texas. And we can see we've got 80 over 64, 83 over 64. Okay, so this is all part of the tropical air. And it's only when we get up to about the Abilene area that we start seeing a change right in there. See, we go from 83 over 60, I guess that's around Ballinger, up to Sweetwater, 78 over 60 with a northeast wind. See that right there, northeast wind. So 80 over 60 in Abilene, so that's going to put the front right about there. How about the dry line air? Let's start with the source region. That's going to be the Big Bend area. Looks like 90 over 30 to 40. And we get kind of similar patterns right there in the Pecos River Valley region. And then it starts picking up to, let's see, 58. Right there around Bakersfield. That's probably starting to hit the tropical air. So we've got a diffuse dry line. I think it's going to be located right in that region there. The front, let's see, let's track that back. Well, we got 90 over 44. That looks like post-dry line air. Winds are out of the south, so maybe that warm front is a little bit further north in that region there, kind of like that. So we may have to move up towards the Lubbock sector. Yeah, so there's a look at that air. You can see the very cool conditions up in Plainview and Amarillo with that northeasterly flow coming down like that. And down here, very hot. Wow, we can really see a difference there. So let's plot that front. Let's see, it's going to be located about right there. So we're looking for mostly a temperature change, like 88 here. Guess that's around La Mesa, to 81 and down to 73. So let's put that in there. 85, 79. So yeah, what I'm showing you here is a mesoanalysis, and I'm going to, yeah, that front looks to be about right in here. So that is our warm front position, and then the dry line, I guess that's going to be just north of, yeah, it's going to be just north of Coleman, tracking back there towards Bakersfield. So this is what we use to refine our surface analysis. So this is actually what we have, and we want to take this and work up our radar and satellite based on that. Yeah, man, that's cold air up there. Definitely jacket weather near Amarillo. And the really important question is, what does that mean in terms of storms? Well, what we figured is that the triple point is north of Coleman, north of Ballinger. So the triple point can be a good starting target there. Also, you can see the winds flowing up towards that warm front. That's also a good location there, although typically out east like that, we find the air mass a little more capped. Another area is, of course, the dry line and also upslope flow along the warm front. So out here, the wind is flowing up the cap rock, so there's some enhanced orographic lift, so that can locally focus ascent right in that area. And of course, all the way up the boundary, there's potential for storms there, and also elevated storms likely in that region, although stratus is likely to be a problem. All right, now let's go to the satellite and see how that pairs up. So again, we're doing that anchoring thing. I've been careful not to look at forecasts or anything like that. I can see that there's less cumulus development out there than I figured we might see. Okay, so the fronts. Well, that matches up really good with our mesoanalysis, although I think the dry line is traced out more in this area here. And a new thing that I'm seeing is outflow. See that little bubble shape? Well, went a little bit too far. Yeah, so right in there, outflow from convection out here, and there's a couple storms right there, and that probably follows all the way out east. Okay, so I'm not sure yet what that outflow means, but that kind of narrows down where we might have some development. I can see there's a little bit of enhanced cumulus out west, back there in that dry sector along the front, which leads northwest. And then up to the northeast, you can see the very stable transverse bands of stratus and stratocumulus. So, yeah, no chance of storms there right now, and I think it would take a while to even generate elevated convection in that area. However, we do see storms going up in the area west of Roswell, and there's a chance that could move east and link up with that boundary right there. So that's one possible convective mode right there. And then a little convection south of Saragossa, southwest of Fort Stockton. That's going to be elevated, mostly orographic, and we know that that's probably going to be high-based since dew points there are in the 40s. And I doubt that's going to be able to reach the moist sector. Okay, so without the benefit of model data, things are a little bit ambiguous how we're going to see development. I do think we've got some convection right there around the Gainesville area along the backside of that outflow. See if we trace that back there. I think that's outflow-generated convection. Yeah, that's possibly along the front, but anyway. And then one other factor I'm seeing for later on is if any convection does get going in this area, it's going to have problems due to this stuff here. There's been overturning of some of the boundary layer in that area, which means the moisture feed, if it works north during the evening, the moisture quality would have problems. So this is definitely a more favored pattern for moisture advection, and that would favor the triple point if that can get going. Okay, so now I think we've got a great grounding into what the models are doing. We should be able to take the high resolution rapid refresh and have a pretty good understanding what it's trying to tell us. And before I go to that model data, I did want to bring up our diagnostic products from SPC. And there, yeah, you can see that kind of confirms that boundary orientation we have, leading from where we got that convection at Gainesville to the Abilene area, back up towards Clovis, and then connects back up towards Trinidad. And you can see the dry line does not show up very well, except down in the Sanderson area. See up north, not much evidence of that. So that's the setup, and yeah, we can't forget the outflow. So it's going to be running about like that. Little MCS just east of Austin. Okay, this is a great workup. Let's look at that model data. So there's our 20Z high resolution rapid refresh. Let's analyze this together. Okay, so 1 hour, 4 p.m., that's about right now. Verifying this, it's breaking out a little extra convection along that front. I'm not sure that this exists, but yeah, that's fine, and it's picking up on that Roswell convection. All right, and we can see by the troughing, it's got that outflow region pretty good, and we can see that outflow right there on the temperature chart, but it shows up pretty well in these severe products like supercell composite. See that right there? It actually shows up because of the way these elements stack up, and it can show up on some of the shear products also. See that enhanced shear north of the boundary. And yeah, moisture. The moisture is kind of in question, and we do see the dry line running through about San Angelo there. Maybe a little corridor of enhanced values in the Coleman area, Coleman-Ballinger. Let's drop a sounding. Yeah, it shows that the moisture starts at 64, tapers off with height, and the Cape is moderate. We do have some steep lapse rates in there, but a little bit of warm air there at 500 millibars, probably due to that ridging. Yeah, see that northwesterly flow there. And another problem is very limited shear. That's not very good. So I don't see much tornado potential on this photograph. And what's the downdraft Cape? 915. That's sort of up there, so we could get some marginally outflowish modes. So let's see what the evolution of convection is. Breaking out some high-based precip there, southwest of Lubbock. Disorganized. Then we move forward, and yeah, just a few specks there around the Lubbock, La Mesa area late, and not much going on. We did all that work for nothing. Well, that's what happens sometimes, but at least hopefully you have a good idea how to work your mesoanalysis. And these are great skills to have, especially when we do get into kind of a busy weather pattern. The problem is, we do have steep lapse rates, but the problem is the whole column is kind of warm compared to, these modest theta E's in the low levels. Compare that to this warm air. I think that's partly the problem we have going on there. Convective intermission 70 to 60. Let me try another sounding. I'm really surprised we can't pull this together. Wow, yeah, see, it's actually showing some good shear there. Where was that at? Looks to me like the parameters get a little bit better as you go up this boundary here. So I don't know, we could squeak out a little something, little rotation out of those storms there in La Mesa. So that might be an area I might want to drift to if I was out there chasing. Because, it is May, and as Tim Marshall says, when it's May, you chase. Yeah, that's the paragraph that talks about southwest of Lubbock, and they're looking for some weak storms with a couple of large hail damaging wind events in a low-end supercell environment. So very, very iffy, and that's how things look for this afternoon and evening. Anyway, it looks like we have better prospects for tomorrow. You can see that enhanced risk centered on Vernon, Texas. So we'll definitely check things out. And looks like that shifts up into Missouri the next day with continued activity on the tail end. So I better go ahead and get this rendered and uploaded. I appreciate y'all's support, and hopefully we'll see you tomorrow, and we'll check out this next weather event in detail. Bye-bye.